Hi guys. All right, as promised, here's your video for the notes sheet that you should have grabbed today in class. If you don't have this notes sheet, it should be easy enough for you to grab a big sheet of paper and divide it into 4 sections like this one is here and stick the word inverse functions in the middle of it. So let's start with the words. We've been talking in class about the sort of undoing function, or if I have a function, what do I need to do in order to go backwards? So when I think of the word inverse, I also think of the word invert, and all of the words sort of, let's talk about undo, go backwards. All of these things are sort of what remind me of inverse function. And if you have a few other words that remind you of the word inverse, you're also welcome to write them in the box. So an inverse function is a new function that undoes an original function. And so if I have an original function called f of x, its inverse is called f inverse of x. So f with a -1, sort of, it looks like an exponent, but it's not really an exponent. It's honestly just poor sort of math notation for whoever invented it. So this just means this is read as f inverse of x. So this here is f of x. This is f inverse of x. So there are some words that you can write, and feel free to add anything else in that box. So let's come down to an equation. Let's say that I have the equation f of x is equal to 2x plus 1. So thinking about what would happen if I put this into a little function machine here, I could make myself a little table, xy table, and I could input a 3. So 2 times 3 is going to give me 6, and 6 plus 1 is going to give me 7. So when I input 3, my output is 7. Let's do another one. Let's take 10. So let's say that I input 10. So 10 times 2 is going to give me 20, and 20 plus 1 is going to give me 21. So when I input 10, I output 2. So my inverse function is what happens if I input 7, I want to output 3, and if I input 21, I can output 10. So what am I doing here? How can I sort of take this 7 and go backwards? Well, the first thing that I'll need to do to 7 is subtract 1, because I want to go backwards and do the opposite. And adding 1 was the most recent thing that I did. So I want to take 7, I want to subtract 1, and then if we look here, it looks like I multiplied originally by 2. So I just want to take this whole thing and I want to divide by 2. So 7 minus 1 gives me 6 over 2, which gives me 3, and that works. So the algebraic way of going about this, and sort of the way where this will always work, is if I have f of x is equal to 2x plus 1, I want to replace my f of x with a y, just so it's a little bit easier to work with. Then what I'll do is I'll write some steps down here. Step 1, swap x and y. So I'll say x is equal to 2y plus 1. My second step is solve for y. So I will subtract 1 from both sides. So I get x minus 1 is equal to 2y, and then I can divide both sides by 2. And I end up getting that x minus 1 over 2 is equal to y. And instead of writing y, since I know this is my inverse function, I am going to write f inverse of x. And this is the equation. So solve for y, and then here use appropriate notation. So if you want to flip your papers over, let's do one more example together. So what if I gave you g of x is equal to, let's say, x plus 3 over 7. So my first step here is to swap x and y. So I'll replace y equals x plus 3 over 7. I'll swap my x and y. X is equal to y plus 3 over 7. I'll multiply both sides by 7, so 7x is equal to y plus 3. I want to get y alone, so I'll subtract 3 from both sides. So here I end up getting that y is equal to 7x minus 3. And I'll use my appropriate notation and say that g inverse of x is 7x minus 3. So this is the undo function for g of x, which was x plus 3 over 7. So there's a little bit about equations for you. Let's talk about tables. Let's just say that I had any sort of old function. Let's say I had -2, -1, 0, 1, 2, and 3. And let's go ahead and plug in 4, 5, 6, 7, 8, and 9. So this is a table that represents a function. And I know it's a function because there aren't more than one x value that maps to more than one y value. So in order to create the table of the inverse of this, let's think about what happened down here. When I had this inverse, I inputted 7 and I outputted 3. I inputted 21 and I output 10. So when we're talking about inverses of tables, it is really just as simple as swapping the x and y values. So swap x and y values. So here is my original function, this guy right here, and this is the inverse. So I have inputs and my inverse. When we talk about graphs, there's a few things that we can talk about here. So if I have that 2x plus 1, so let's talk about f of x is 2x plus 1. Here's my y-intercept. And I can go up 2 and over 1, up 2 and over 1, up 2 over 1. So here is my f of x. So let's just think quickly about what this table would be like. I have -2, -3. I have -1, -1, over 0, up 1, over 1, up 3, and over 2, up 5. So let's take a look here. This is my x, this is my f of x. Thinking about what we just talked about up above, my inverse would be -3, -1, 1, 3, and 5, -2, -1, 0, 1, and 2. So here's f inverse of x. Or I could graph f inverse of x is x minus 1 all over 2. So let's plot these points. I have -3, -2, -1, -1, over 1 and up 0, over 3 and up 1, over 5 and up 2. So I can come in here and I can nicely connect these dots, and I can connect these ones in my orange color. Awesome. So looking here, sort of what do you notice? A big takeaway piece for graphing these inverse functions is that they reflect over the line y equals x. So y equals x is this sort of perfect diagonal line right here. All inverse functions will always reflect over the line y equals x. So there are some notes for you about inverse functions. If you go and look at problem number 8 from your problem set, you should now be able to finish solving that problem from your problem set. Come to class with questions tomorrow, and we will go over them before your quiz on Friday. Good luck, guys.